Welcome back to Made Up of Wires. Oh, I didn't bring it. I was going to hold up Metal Gear Solid. Decompiling Metal Gear Solid today. Actually, I think there is a Metal Gear Solid decomp project. I haven't looked at it lately, but it might be fun to look at. Get some more Konami code in there. Not the Konami code, but a Konami code. We're decompiling Castlevania Symphony of the Night. Working on the Richter boss fight. The LP, good to have you. YouTube chat. We're going to be looking at Richter a little more. I think what we'll do, we have all of these breakpoints. We'll work on this main switch again, get a little further on that. And then I think we'll put breakpoints in each of the switch sections, and that will help us determine what the think step is. And maybe we'll learn something about the game. So if you're not familiar with the Symphony of the Night decomp project, go to soten.z.dev. You can join us in Discord, see what we've decompiled on GitHub. Very friendly project. Feel free to join if you are so inclined. Yesterday we started working on one of the bigger functions in the Richter boss overlay, which is Richter thinking. That's the name we gave it. And it's a huge switch. And each of these cases in the switch is some action that Richter is going to take. And so one of the things we need to figure out is what each of those actions are. It looks like there is about 50 of them, quite a few. We don't have to figure them all out today, but maybe incrementally we could go through and maybe get the first several. There's some things in here that aren't quite matching, so I may want to go in and grab the PSP version of the game if we can find it. This one is particularly long, so my guess is that we could probably find it by size. There's a couple different ways when you have different versions of the game compiled by different compilers with different settings, how you can find the same function, the same bit of assembly code between two versions. And I'll go through how I do that. It's not always easy. Sometimes it is. The easiest thing we have here is a nice string. That would actually probably make it pretty easy. Hey, does it good to have you? LP, you should get into decomping. It's fun, especially if you are programming already. It's not that much of a stretch to go. I say that like anybody can do it. It's actually not terribly hard. If you understand the compilation process, the decompilation process should make a lot of sense. The big issue is optimizers screw everything up. All the assumptions you make, all the things that optimizers decide is undefined behavior that they can do whatever they want with. So let's kind of review this function yesterday, look at some of the areas where we're not quite right, and then maybe do a little cleanup. I know for sure that there are some additional fields in the GRIC player state global that we can map. These other globals, if they're above 1C, they're probably in yeah, I think these are all in BSS, which is uninitialized data. That makes it a little trickier to determine what it is, but a lot of the state for a boss is uninitialized to start and then gets initialized either in this function or some other related function. But we can kind of tell some sizes, maybe, of things. So kind of to start out, we're missing one stack variable. So I tend to aggressively get rid of local variables when I can. And sometimes that works out just fine, and sometimes it doesn't. Looking at this, facing left. We have some ordering differences here. Just get rid of the equal sign, fixes everything. That was an easy one. What percentage did we get? We got 0.2% from getting rid of that character. Sounds good. There is this nor with all of this as well. So what this probably is actually, we see this sometimes as well. Something like this. Not quite. Let's try going the other direction. Yeah, something else is in here that that we'll have to figure out. Actually, some of these also may be misordered. We'll figure that out in a bit as well. So we're missing a nor and a shift right. Or sorry, yeah, shift right logically by 16 bits. That seems like kind of like an absolute value type situation. We'll look at that in a bit. Player status. So we have a bunch of these constants that are actually enum flags. Look at those in a bit as well. 36. I did just switch this. Usually in this code there is not a lot of less than equals or greater than equals. And so when I see it, I tend to switch them if possible. In this case, though, it might legitimately be there. There's a negation up here as well that is missing. We'll figure all those out in a bit. I don't want to focus on too much on the minutia. I do want to see, is the general structure of this looking fine? And so far, yes. We're missing that stack offset. There might be something more down there. Here we have potentially a hint at what our missing variable is on line 103. We're using a S2 register in addition to the S1 register. S registers are Romy, yeah, I agree that it does seem like a Boolean conversion for less than 0. I agree. I think that they're yeah, I wonder if this is written a different way. I took this implementation from BO4. And I could spend some time going through all the variations of how to determine if a character is facing left or not. But I would rather just grab the PSP version and fake it till I make it. All right, so here we have a return, and I think that return is going to be wrong. So in a bunch of these cases, they are returning, and I might have incorrectly change these to breaks when they should have been returns. It looks like if any of these cases happen, let's see. Are we going to break? Are there a few cases where we are going to break? So if it's less than 8, it looks like we are going to break, and otherwise we're going to return. Let's try that and see how that works. What I'm trying to do is get rid of this EFC here on line 123. It is possible as well that this final case is just a break and return. And yeah, that looks better. So even though these constants are different, 354 versus 368, the way that decomp.me's diff works is it recognizes them as the same place. So we are missing, it looks like, one offset here. Still 1, 0, 1, 2, 3, 4, 5, 6, 7. We can't get any higher than 7. I think EFC and F50 are the same. So we do have quite a bit that's missing. That's like 60 bytes of code that's missing. So a bunch of stuff down here at 566. So that seems like something that, well, I'm not going to go into what it may or may not be. Let's, while I'm here, let's figure out the rest of these and try to determine where this was. I got rid of my pad symbol already. I'm not logged in even. I was working. So yesterday I spent a long time ranting about Python and my love for the language, and spent far too much time yesterday poking around at SPIM and other things, and it was suggested to just rewrite it in Rust. And as I was syncing my branch with SPIM, or my fork, which hasn't been updated in quite a while, I saw pull down from the GitHub the SPIM RS branch, and there is an effort, it looks like, to rewrite SPIM in Rust. And basically, I think it would just be fast. It didn't even have to do anything different. It could be a function for function rewrite, and it probably would be fast. So what do I want to do? I want to look for symbols, US, Bobo 6. Ooh. Looks like I have an old buffer here. I don't think that's doing anything. So I based all these other addresses off of padsim, so we're going to keep doing that. And basically, I need to go through these and calculate the offset. Lots of fun. Well, so yeah, I spend a long time trying to optimize Python, which is a fool's errand. 6. Looking at arrays. And what kind of language has arrays? 72. The other thing, so I did spend not a long time, considering writing a segment table, but again, like, if it's going to be rewritten in Rust, I don't really want to touch it. And I will just put up with the bad performance until that happens. Wrong order. I found some interesting things in Splat, though, as well. And one of them was Splat does some image conversion for us to PNG, which is nice. And that actually takes quite a while as well. And from what I can tell, it's just reading bytes, like a blob of bytes, and then taking an 8-bit value and converting it into two 8-bit values, where one is masked the first 4 bits and the other is shifted over the top 4 bits. And that takes a long time for another case where Python's taking a long time. It seemed like something maybe NumPy or something could help with, because it really just basic bit twiddling. Even an old system should not have to take much time to do that. But Python does, of course. All right, so I have all my offsets here. Now I'm going to go back and look at player state. So all of my offsets are based on this. So I'm going to be taking those addresses, adding these other offsets, getting a new VRAM address. And getting rid of my OX prefix unknown 46. And then just annotating them here. And I'll come back later and do all the replacements there. What was nice about the doppelganger is I think that this was aligned on the same, what's the same last 4 bits as player. So I knew when I was right or wrong because the last letter was always the same. Oh, Python bytecode. That's interesting. That sounds like something I would not like. What is the Python is the Python VM? Is it I don't know. I've looked at old Ruby, C Ruby, and written C extensions for that. I've written C for Java. Is the Python VM similar to those? One more of these. I'm worried that this one is not going to be. Oh, it is. Unknown 54. Do I have these out of order? I screwed up somewhere. Shoot. Oh, yes, I did. I see. This is outside. This last one is outside of the player state. So assuming I have these other offsets correct, this last one is not part of GRIC. Yeah, in general, for interpreted languages, that's usually my goal as well. Just as much as possible, get to C, and then you're not really leveraging that particular language. Sometimes worth it, sometimes not so much. All right, how did that help us? It hurt us, but that's mostly because we're going from constants or automatic global names to these others. Oh, I want to bring these back. Bring it back. And I want to add symbols for all those. And then I won't have to deal with this in the future. And actually, it might be a good time to re-export this. I find it difficult to, especially with something like player state, which is really big, I find it difficult to deal with the offsets when I'm looking at decomp.me output. All right, so we have those symbols as well. And now back here. All right, so we have we know what the Richter think step is. This other global, nothing there. Let's go grab the PSP version, and I'll probably re-export this as well. We'll do both of those things. And we'll keep going. So we want to look for the think step string. While that's going, I'll look for that. All right, so or F38 is how that one ends. So it should be the PSP equivalent. We don't have any primitive structs in here, so context doesn't need to change. The primitive struct on the PSP is different from the primitive struct on the PlayStation. We don't have a jump table. It's actually going to be valuable to have the jump table, so I'm going to go back and grab that. For whatever reason, I haven't looked into it, so I can't tell you specifically why, but we don't have migrate RO data turned on for the PSP. Migrate RO data will stick things like jump tables right in the same assembly file, so we don't have to go find them ourselves. It's not enabled for the PSP, or if it is, it doesn't work, and I don't know why. Not looked into it. Oops. So when we have to grab each of these that are being used and kind of build up a RO data, our own RO data section. It's not. It's a little tedious, but not terrible. That's the only one? I don't believe that. We have this gigantic... Is there another function that prints think stuff? Yeah, these are the same. So this is just loading the high 16 bits and the low 16 bits. So it has to be done in 2 instructions. So that's why it shows up twice. I'm a little surprised that this would only be a single jump table. Let's try it. So I'm going to copy this just in case I have to do something else. We know what the signature is, which is no signature, but M2C, by no signature, I mean it's a void. GCC should be able to figure that out. Hey, Willie OD. Regular grep in 2025, absolutely. Unix is my IDE of choice. Oh, and that's what it was. And it did grab the whole outer switch, which is nice. So when I'm bringing in PSP code, usually I just take the PlayStation code and dump it in the PSP scratch. I did look at these, and I do think that they are supposed to be LUT. I'm not sure what I was thinking, but those should be around. The T being timer. And they're a la carte timer offsets because that's usually the player. But when you have player bosses, like bosses that are... Oh no, stop. Don't fuck. When you have players that are bosses, a lot of the same indexes are used. So we're going to see some things that you may or may not want to see. But we'll see ordering things that are different. So we have a bunch of references to player X, position X, that are not showing up here yet. And maybe that's because they're out of order, or maybe those variables are never used. So GCC just eliminated them from the produced code. A lot of things that are the same. So our jump table actually looks right on, except for this one case here. And I'm still a little surprised that the jump table is all in code like that and not a separate table. Excuse me, a branch that's going to the wrong place. 54, let's look at that quick. Yeah, so the default case, it looks like is it looks like case 0. Case 0 may originally have been at the end. All these other ones are showing up in the right place. We'll look at that in a second. Yeah, and here... no, I'm not quite sure. 404 is not too far away, and this 404 is jumping right to the end, 84. Oh, our default here. Okay, so this was something that M2C put in, and I didn't get rid of it, but that should fix that. This actually probably is a good time to review all of the extra returns that are in here, and if they're returns that don't actually do anything, getting rid of them, or things like this where this is probably an else. Because if it's an else, then we don't need that return. And we don't need these returns. And that's probably not going to change anything too much. And interesting, this version of the function looks like it should be maybe an else for each of these. Let's go look at the decomp for this PSP version. So again, this is how Richter, the boss in Symphony of the Night, decides how he's going to attack you, in which ways. And so we started with the PlayStation version, now looking at the PSP. I'm not familiar with any major differences between this boss fight between the two versions of the game, so I'm going to assume that they are the same. Yeah, so we have something that's slightly different here. We don't have a variable for player distance, and so this becomes an else if. And so some of this is a little different. This makes more sense to me too. Greater than. And so if it's greater than, we're going to call this function, and then we have our else. And so this looks a little better. We're going to have different function names because those are automatically generated. And it's just based on the VRAM address. So they're the same functions, just with different names. And then we also have different constants because button values are different between the two. Let's actually go back. I started talking about the facing left at the beginning. Let's look at how that's implemented on the PSP. And that might tell us something. I put a pre-decrement here. No reason to really. The pre-decrement, I try to leave for cases where it makes a difference. So if you're not familiar with pre-decrement versus post-decrement, when you're looking at the value of 3d8 and then the decrement operator, which subtracts 1 from that, when does that happen in the expression? If we would put that, in this case it doesn't matter if it's pre or post because nothing else is happening there in that statement. If we'd put it up here, the if would look at the value first and then decrement. If we put it here, the decrement would happen, and then the if would look at it. When it's all by itself, it doesn't matter. I tend to, like I said, pre-decrement only when it makes a difference, because then it stands out, and you can kind of, you see, oh, yeah, I probably should think about what that's doing. Here is our global pos X, and we have an S2. The PSP is really good in this non-optimized version of only of reserving the S registers, like S2, for variables. Most of the time, if it's in an S register, you know that it's really a variable. And so we should have at least 3 variables, S0, S1, and S2, and we currently have 3 variables. We'll have to see what those are. Facing left, I'm a little surprised, is a unsigned. Probably just use a bool there. Bool ends up being 32-bit for this system, and we don't have to worry about byte alignment or anything like that. So that should be fine. So we have the assignment to 2, the assignment to 0. The facing left equals false. So every time we see var s0, we need to think facing left. The Rick minus player subtraction, and it is a greater than or equal. So we'll leave it that way. Now we have this player subtraction. And we're doing the exact same thing. And I think we have this elsewhere. But let's go grab it. So this is S1 is going to be a different variable. This is we call it player distance X. Oh, it's not being used. I thought this was. Oh, I just got rid of it down here when we were doing that other stuff right here. So GCC optimized this away. So my guess is that this is never actually used, and we could go look around for temp v1. But because it is there, the optimizer, GCC optimizer, has to consider it. And so that changes some of the decisions it'll make, even if it's never used. Let's go look at temp S1 and see where it's used. Oh, it is used a few places. So if we go down right before case S1, no, this is in case 0, sorry. So it looks like I had global pos X. Where this should have been player distance X. I trust the ordering of the PSP more than the PSP. So when there are things where one side of the branch is coming first, I tend to want to follow that. But the returns, as opposed to the if-else, that is not as important. This, I do like this construct though, so we'll take that. So this does have, this ends up being a little different. So 0 and 6 end up calling with the 6. 7 is 7. 1 is 5. This may be a difference between the PSP and the PlayStation, or it may have been something that I screwed up on. It does have the default case, and I thought that we tried that yesterday, and I thought that it did not work. But we'll try it like that and see. Oh yeah, look at, so let's reorganize some of these cases. All of these should just be breaks. So this has 0 and 6 doing the same thing. It has 1 way down below. Let's look at the instructions there. 113. When we have the extra SEH is sign extend half. It's taking a 16-bit value of, that's what timers is, a 16-bit signed value. When we just want to see if it's non-zero and don't want to have to do the sign extension, we can just check it for truthiness. And here is our switch, which is all jacked up. I'm gonna put it back the way that it was. Get rid of this again. And so we have register differences, which is not an issue. We do have offset differences here, so we should be getting the same RO data here, and this is where our RO data is coming from. The RO data possibly is it has a strange offset. Somewhat curious that it's 0 and 18 versus 18 and 0. I'm not sure what's causing that. Then our all right, so I do think that construction is correct, with the exception of the RO data being out of order. Changing the order here doesn't seem to make a difference. So I'm not sure why. The order down here is wrong as well, and they're both in completely reverse order. Strange. On 123, the return value is being put into A0. Not sure why, or V1 instead of A0. Not sure why that's happening. Oh, I see. Because we need to break. We should be breaking in all of these. Or maybe we should be returning on all of them. No, yeah, I'm not sure. Something else will, I think, end up triggering that register difference. Let's go back over here and see where we were. So yeah, M2C doesn't generate the right jump table there. A little surprising because we have the RO data, so we know what offsets there are in that table. Hey, Supreme Quetzal, good to have you. Dizek suggested returning on the 2345 case. I don't think that made a difference. We'll try it though. I would be a little surprised if they mixed returns and breaks, since I have one idea. We'll look at it and see. What if these were returns? I don't like this idea though. It's possible that this is the way it was written, and then this just falls through. Yeah, no difference there either. There's like a million different ways that this could end up being the same thing. it's possible as well that I don't have the function signature. We could try that. MetroWorks is more sensitive to that than GCC is. If it knows what the signature is, so by default the signature for any C function is returning an int and taking any number of arguments that are all of int size, and sometimes that affects how MetroWorks generates code. So if it's returning an int, it's going to overwrite the v0 register, and so the caller needs to save that if necessary. But I don't see any reason to really do that. And sometimes it's just there are various circumstances that cause the compiler to want to use some registers and not others. And sometimes it's not even related to this section, it's something else completely. So now we're down at case 2. Another switch. So when we see masks like this for GC or for MetroWorks, it just means that the value was a 16-bit value, but we're doing a comparison, a register size comparison, which is 32 bits. And these are inverted. When you start untangling all this, it starts to look much, much simpler. So here there's an explicit case 2, and this is another, let's get rid of it and see. We should be able to see that show up in, it's not going to be in RO data, but we should, oh, what did I do? Did I not, oh, press the wrong button. We should be able to see it, whether or not it affects the switch code generation. And yeah, we see a bunch of cases in here that aren't being handled. So there's an explicit check for 8. Or no, are we passing 8 somewhere? No, that's this. No. Are we on the right line? No, I'm not in the right place. Looks like there's one more else up here that I missed. I'm trying to see what is going to jump us to this 7.1c. $140. Yeah, it's hard to know sometimes how these end up getting written. It looks like this is else if global position X is less than 40. And then we're going to do if all that, and then another else, and we're going to end with this code. Same thing down at the bottom here. And it is duplicated. It's not like that control structure. GCC optimized it to be the same thing. But MetroWorks did not optimize it. And so we know that there was this control structure, basically. And that's fun, right? It's going to compile to the same thing on both platforms, but this is probably a more accurate representation of how this was originally written. And we get a lot of clues, a lot of forensic evidence from MetroWorks about all that. All right, so let's go back to this case 2. Now that we have that code back in there. All right, so we do have a load immediate 2 in ours, as opposed to a load immediate 1. I'm going to try adding the case 2 here and see if that does it. It does. Sometimes I struggle with what order it's going to do these checks in, but decomp.me caught it. There actually was another label there. And we need that for a match. It doesn't do anything. It has no functional value. GCC is not going to show us that exists, but we need it to match on the PSP. Some move instructions here that are in the wrong order. Are these branches correct? It looks like it. Sometimes there's random moves like this. My hope is that as other things get resolved, that those will fall away. Sometimes they do, sometimes they don't. And I'm not going to spend any time on them, because if they fall away, then I never had to consider them. I spend time fixing the things that I can control and avoiding the things that I can't. This is kind of a similar duplicated code in both of these branches. It compiles to the right thing, so I'm okay with it. We're missing... It looks like possibly down here there's one of these branches is missing. So let's look at case 5. So again, the numeric values for the pad are different between the PSP and the PlayStation, so we can't look at one of those and trust it over another. Oh, this is implemented as a switch. That's interesting. So the way the code gets generated, M2C, which is what we use for decompiling, and we could probably catch that. All these are actually probably switches now that I think about it. The way that we M2C catches it is through heuristics. In this case, we have an additional case 1. Supreme Quetzal says, I think I had this patience before before decompiling. I think any kind of programming requires patience and being detail oriented. I struggle a lot with transposing numbers, and so I know more so on this than most other things. Most of the time, you're writing business logic and other things like that. You're not dealing with a lot of numeric values in code, or at least I, in my professional life, have not dealt with a lot of numeric values directly in code, not offsets and addresses and all this other stuff. So this has really like kind of exacerbated my my weakness for transposing numbers. I do it constantly. I'm going to go back to this one and see if I can rewrite that as a switch as well. And we'll watch the assembly as it's going. The other thing that I've kind of realized lately, and it's kind of a life regret maybe, I think I had probably 85 to 90% of the skill set and knowledge to do this 20 years ago. And didn't know it. MIPS, I knew all about MIPS. Loved the PlayStation. There's probably some file system stuff that I didn't know until about 5 years ago that I could have learned. But what else? You kind of realize as you're going through this that, CF3CC, I bet this is think step _s. I'm going to go make a note up here. So this is common for entities. We call it step and step _s, which is like substep. Anyway. Yeah, that's true. The tools are mature now, and they weren't 20 years ago. That's absolutely correct. Could we have done a matching decomp 20 years ago, or would that have even been something like that people would have thought of? Probably not. A lot of the modding and like randomizer stuff definitely could have been done 20 years ago. But even just looking at games and how they worked, and like I got into this about 5 years ago looking at the Sega CD, and the first thing I noticed, I had done Motorola 68HC11. That's a Motorola 68K. It's so similar. Embedded stuff with Motorola chips. Looking at the Motorola documentation, like you start program execution at by looking at a jump table that's at a specific area in memory. Like it's so obviously like an embedded system from the 90s, 80s. I knew all that stuff and didn't know to look at it until recently. But then a lot of that background helped when I found this project. So yeah, kind of. Can you give me an estimate? How much is estimate? Oh, they're gonna pop up in the way. Estimate about how much is decompiled. I think we're about 40% of the way done. Let's go look at, the graphs are confusing. When you put your mouse in exactly the right place, it'll tell you where each of these overlays is. Unfortunately, these aren't all the overlays, and so the better thing to do is to get an overall sense of it. And some people if you go to the Discord, the Soten Decomp Discord, there are people working on other visualizations for this as well that can be used elsewhere. But this has more details about the overall. I put all the overlays here a month or two ago because I think it was Gaming Esoterica, whatever, some YouTube channel. They were saying that we were almost done, but that's because we only put the overlays that we had started. So I put all of them here. and so this gives you a better sense of where we are. So the ones that are 100% are 100%. Hey, Nate, good to have you back. Oh, just got paid. Always ordering groceries. Do you have your groceries delivered, Nate? I could never bring myself to have groceries delivered. I guess I do have groceries delivered. We get our groceries through Walmart, and sometimes you have to get $35 worth of groceries just to do pickup, and we do pickup because that's convenient, and it doesn't cost anything. But then they're just like, hey, yeah, we'll give them to you at your house. It's never anything fresh though. It's all, whatever canned stuff. Anyway, this is where you can go to see. I do want to look at Weapon 1. Maybe I'll do that after Richter, or when I get bored with Richter in the middle somewhere. Weapon 1 should be the same as Weapon 0, except it's for the left hand as opposed to the right hand. And I'm hoping that we can reuse all the code and just have to build a new binary. And maybe there's a few macros to switch there. I haven't looked into it at all, so I don't know. Recently, so before this, we were working on RTOP. Is it working now? Yes, it's working. So RTOP is 100%. Reverse top, or RTOP, it's small. There's not much there. There's like 4 rooms. It was done in like 2 weeks though. And a lot of that was because it shared so much with top. The hard things and the things that take a long time are you get a new enemy type that hasn't been seen before. And now you have to possibly go into drawing logic that hasn't been done. Anything with 3 drawing logic is going to take a long time because it's unique and different. And at least for me, it hurts my head. Other people might be able to get through it a little easier. All the bosses are going to be hard. All the bosses are probably going to take a month or more for one person to go through. BO4 and RBO5. Those took like 3 months. And I was working on them both at the same time because 90-ish% of the code plus was the same. So there are times where we can kind of leverage the similarity between them. And I'm doing Richter because Richter is in top. And so all of the top code for drawing stage-related things is going to be somewhere in Richter. And we can leverage that. RBO5 had some... where is he? He's in Reverse Caverns, I think. So there's some Reverse Cavern stuff that got done with Doppelganger 40 that we haven't seen yet because we haven't done that for the stage overlay yet. Maybe that answers that, I don't know. PC Diablo 2, interesting, in 2018, 2019, that's interesting. So I will cross saying, do I know what the oldest decomp is? The one that made me aware of it, and probably is not the oldest, but was the Mario 64. And we use a lot of the Mario 64 tooling, because that is also MIPS, and so we can leverage a lot of that. When was Mario 64 done? That's got to be around that same time period. 2019, yeah. So that was the first I heard about a matching decomp. I had obviously people have been decompiling stuff for a long time. But that was the first matching decomp. And if you're not familiar with the idea, Mario 64, or the Super Mario, what do they call their project? You just call it Super Mario 64, SM64 on GitHub. A matching decomp is going to have code that will recompile. So original code developed by people who are not the original developers, but compiles to exactly the same thing that was shipped on the retail game. And that opens all kinds of possibilities. Disick says it's Diablo 1 decomp. That is interesting as well. There are they're not decomps necessarily, but I was always a fan of like what id did, where when like id Tech 2 came out, they would open source id Tech 1 and basically release everything to build the game except for the game assets. I always thought that was very admirable, and like that in some cases, I think for Quake, I don't know, Doom 3, they ended up going back to the was it Doom 3? One of the versions, maybe it was Doom, maybe it was regular Doom. They did a mobile port, and John Carmack was still involved with it, and used the open source implementation in their mobile port, which I thought was really cool. All right, let's try getting some of these, rewrite them as cases. Nate says he uses the Kroger app. I always forget which stores are Kroger. We have Kroger, some Kroger-owned stores here. Is that Safeway, or is it Albertsons, Fry's, one of those? Let's see, we need to find our 190 here. To me, the joy of a matching decomp is the puzzle solving. That's what I like. And that's I mean, I obviously I like Symphony of the Night, otherwise I would not spend so much of my free time doing this. Let's look at this. So this did not produce the same code. Oh, because I had too much. No, that was right. That's equivalent. Yeah. Oh, that's a bummer. I would have liked that. Let's try a knot here. I don't think that changes anything. Sounds good. Aren't they hard? I guess I won't say anything more. I was in Milwaukee over the summer and imbibing in such things in Milwaukee and the entire state of Wisconsin, to the best of my knowledge, is not legal. It is very verboten. I have not been in an environment with as much engagement in the described activity in my entire life. It was pretty crazy. All right, so here we have loading of some globals that seems to be missing. And it might be this facing left calculation. What would be my dream mod? I think I'd probably So shout out to Zynamo every episode for the Maria mod, which is awesome. I do think what I would like to see is runtime selection of the different, at least the different Marias, so the two different Marias. I think that would be neat. I think having the randomizer at runtime, so when on like the load screen, allowing you to enter a seed and having everything be randomized based on that seed, I think that would be neat. And I really want to do a performance mod, and I may work on that separately and put that in a separate branch. So on the PlayStation, can we get like the life up animation to run at 60 frames a second instead of slowing to, you know, low teens when you get a life up item. I'm a simple man though. Honestly, like I would like this to be portable at the end and see a playable port on modern hardware, like a native port on modern hardware. I think that would be neat as well. All right, so we have some different values. Not too concerned about that. What I want is, oh, okay. So this is interesting, and I didn't catch this at first. GCC will do this a bunch. So the original code, or the code that is on the PSP, is reading this pad sim and then doing an OR equals. And if we look at the values, I was looking at this, the values really are just shifted over by 8 bits, depending on what the button is. So 80 should be 8,000 here, and 20 should be 2,000 here. But we're not getting that. We do get the 4,000 versus 40 over here. So why are these so different? That's because GCC looks at this and says, I know that pad sim was set to 4,000 up here. So when I do the OR equals, I know the result is going to be C1000 because no other function has been called. I know that this field isn't aliased with this other field. So instead of reading this value again, doing the OR operation and then writing it back to that place, I'm just going to write it because I know I can pre-compute that value. But that's not what is happening. So we can't get a matching decomp on PSP if we do that. Mozilla saying, I wonder if we could recompute the calculations in memory. I'm sure there's a bunch of things. I haven't looked too closely into what is happening. If it's the number of primitives, if it's calculating their position each time. All right, so let's keep this going. These look backwards. So we're doing the global position check first. Temp A0. All right, so we're this is happening. Doing this decrement. Doing the let's do this way. This is a case where I would pre-decrement. Check that. Yeah, you would think that the number of frames necessary for that animation, it would be a relatively small lookup table. Or even if it's not in code, it could be pre-computed once. Velocity X is a fixed. I've talked about fixed a lot. I'm not going to go into details about what a fixed is right now. Just know that it is an alternative to a floating point value. I think these are going to be kind of the same as other ones. GCC has flipped these all around. No problem, Supreme Quetzal. My pleasure. That's why I'm here. If I didn't want to answer people's questions, why would I be streaming? Duh. This is a... Didn't notice that to begin with. Looks like we have the same kind of structure as before. Maybe not. Maybe not. There's an extra velocity read here. Oh, I see. So this is else if, and then this is, again, it's flipped around backwards. So let's double check how this is going on the PlayStation and see. We're getting closer over there. We were at 95. I do need to fix my enums here. I don't know why I thought that these were wrong, but yesterday I did think that they were wrong and I changed them incorrectly. So we got 1% closer. Almost exactly 1% closer. All right, so I think a lot of this is going to be the same. I don't think there's a lot of sense continuing to go through all 50 cases and kind of make the same changes. The basic takeaway, though, from this right now is there are some cases in here which should be switches. If we only have 0 and 1, it's probably not a switch. This global that I've highlighted here is a sub-step, and often that's how different entities control their behavior. We have a primary step and then sub-steps within that, and it's a big state machine. GCC likes to optimize in a way where the positive branch gets turned into the negative branch, and we have to switch a lot of those around. And as we do that, things start looking nicer. So we'll I'll work on that a little bit. I'm going to do something a little more fun, and that is finding the breakpoints for the first several of these, and then we'll play through and see when they get hit, and then we should be able to tell, hopefully, what the think step is. We can do that a couple different ways. We can watch for writes to this global variable, and that would be fine. Or we could look for execution at any of these spots. This is one of the reasons that I think having GDB integration. We have GDB server on DuckStation that we can use, but it has never worked, and we don't have the dwarf symbols are not being, they get stripped out before the point that we can use them, which is unfortunate. So I'm going to go to the jump table. I think that's the easiest thing to do. Let me find that file. And then we'll add some breakpoints. Let me see if I have DuckStation set up correctly. I do. So where are we? This is Richter thinking. So what I want to do first is determine what order the jump table is in. It should be indexed by the numeric value that we're checking in that switch. I just want to make sure that that's the case. So where does this label go? And does it go right to the front? And it looks like it doesn't necessarily. Maybe it does. Where's our switch? Yeah, so the font print here, this is where the think step is being printed. So we can take these addresses right after each of these labels. Maybe not each of them. We probably have to go back up to and look at just the L labels. We can grab those, and that will tell us what the think step is, or what code is being executed, and then we can see when those changes, or when those change, and then kind of document each one of those. Oh, interesting. So Nate's saying that when BizHawk and DuckStation reset, they write different values. Is that they write those values at the current program counter or to a specific register? And that's interesting that there's different behavior, and probably would be a good patch for DuckStation. I don't have any allegiance to DuckStation, really. It's just the one that I got to work for the use cases that I need, and it works on a Mac. That's a prereq for anything that I do. I'm going to get rid of all these get rid of all those. And so we're going to start with this first address. Add that in there. I'm going to back out of that fight as well. Look for the other L801 breakpoints. And we'll go through maybe the first 5 and see if we can get each of those to trigger. It'd be fun to make a poster out of like this state machine too. I sometimes think about, can we what kind of crazy documentation could we come up with? So we have 2 things. We want to look at the TAMA step eventually as well, which is, as was pointed out earlier, that is the what is the soul orb, whatever shaft is controlling that, you can see with holy glasses. The judge debug is interesting as well. I didn't see that earlier. And do I have... Let's see if I can... Yeah, I can back out of that. And we'll get going. Of course, I need to configure my controller again. That's not it. I don't like that. Oh, no, I went back there. What happened? What happened? Was it 1? I think it was SDL1. Oh, come on. Let's save and try again. DocStation does that to me frequently. Last time this happened was because I didn't have a controller. Oh, there we go. All right, so we have our drat. I probably have to put the breakpoints in again because I don't think that state gets saved. Yeah. Let's go to the top. So basically, I just want to see each of these get hit, and if we can kind of tell what Richter's doing when each of these gets hit, that's good. The other thing that I think mod-wise, there's a ton of entity code that is identical between overlays, and it's a really trivial thing, but would moving that into DRA, or moving all of the entities into DRA, how much of that could we get into one overlay and load into memory? The code shouldn't be hard, and then you would just have the other stuff. And how much could you share to then be able to load in arbitrary places? I do want to come up with a scheme for how to reference all the pieces of an entity so that we can easily go. So step 13, by the way, is cutscene, it looks like. So we're at, shoot, I missed that. So following the item crash, we're at BBC. 5 BBC. Just step 1. So over in decomp.me, I'm just adding notes here. Sorry, case 0. I'm gonna see if he stays here or not. So he goes through a couple iterations. If we look back at what is happening here, it's not obvious. I don't think we have this A14 function yet. Yeah, that one's not done yet. It's possible that this is setting this step. But we don't have that one done. So we can't see. And we keep getting back to this step 0. So this kind of seems like a default, like, decide what you're going to do next. So we, at some point, we did hit, it looks like the holy water item. And we keep hitting that step 0. So it seems like kind of a default starting point for the other steps. So let's disable that one and see if we can get to step 2, 3, or 4. Oh, we hit one. So I just jumped and we're at 5C. 5C. So that is step 1. And let's see what he does, if he's going to jump or do something else. So he decided to throw the axe at me because I'm in the air. Oh, and we should look at, actually, I'll try to get this where you can see it as well. We have pad sim 8,000 and 2,000. We can see what those are. And when we look at that, you can see that it's kind of obvious what is going on. So, oh, actually not too much. So we're either going to be moving left or right, depending on which way it's facing. That's obvious. And then something less obvious. So this does look like possibly an attack decision, though. We got to think step 8. Think step 8 may be throwing the axe. We haven't gotten to there for code cleanup yet. Pad sim is 1080. 1000 is up and 80 is square. So yeah, we are doing our item attack. I don't know if, or sub-weapon attack. When I unpause this, I am going to get destroyed by this axe. All right, and we're back at 5C again. Okay, seem to be, yeah. So this seems like case 1 is, yeah, choosing an attack. That's my guess. So let's move on from there. Oh, we hit another one. 5F68. Five 6F8 is case 3. So he hit me and then he decided to jump. And what do we see in case 3? Pad sim is 80. 80 is square, so that is an attack. So it looks like this is maybe a plane attack with attack. All right, now we're at 5FD4. 5FD4, he did oh, what is that? His rush attack. I can't think of the name of it right now. 5FD4 is case 4. And again, so with Doppelganger, we don't see this. There's usually a shortcut for how this is done. Pad Sim is 8, which is R1. And so what they've done for simplicity, so normally you would do up, down, roll to the direction that you want and attack. I believe that's yeah, the dash. Thank you, Disick. I think that's the control for the dash. They don't want to input all those instructions in the dash, so they look at what else could they do, and they use pad R1 for the dash. So later on, we'll do a small mod. Once this is all done, we'll do a small mod to give the second player controller access to control Richter, and we'll see that R1 lets you do the dash without having to do any more complicated input. All right, so we have all of them. That's actually faster than I expected. All of them except case 2. We haven't hit yet. And knowing what a bunch of the buttons do, and if we put the buttons enums in for all of those constants, we probably could figure out what the cases did as well. But it's more fun to play the game, I think. All right, so we did hit 5E60, which is our case 2. If we look at the case 2 code, it's a little longer. Pad Sim is 40, which is cross. So this is a jump. So yeah, it's looks like it's trying to make a decision about whether to jump or not. Let's see if we get a jump here soon. Yep. And I got defeated, which is not uncommon. So I don't purport to be the best player. I just like the game, and beating Richter here anyway would get us the bad ending, so we don't want to do that. We kind of have to. They have to die? No, we have to not get to this point. So we will have to go get the holy glasses in the future, and we'll look at Tama Step and some other things like that. I wonder what the right thing to do. Oh, that actually seemed to work. Transform into bat. It doesn't matter though, does it? Because even if we win, we lose. So let's pause it there. So we have a few of these. It's going to take a little while to go through each of those cases. It's also going to take a little while to clean that up, but we're at about 96%, which is not bad. It looks like I put an extra space here on line 208. I'm getting too excited, stopping the debugger. Typed in the wrong area. 85% on the PSP isn't bad. Still 96% on the PlayStation, and we'll get there. Let's look at the top. Is that any better? Still kind of out of order, but hopefully we'll figure out. I think the global position X, I think I have that wrong in some places. And so when we get closer on the PSP, we'll work out some of those registers. We're decompiling Castlevania Symphony of the Night, and you can go to stoughton.z.dev to learn more about that. I appreciate everybody showing up in chat. Like, subscribe, do all the things. And come back tomorrow and we'll do some more Richter. I don't know if I'm going to focus on this state machine function unless there's a huge outcry to do such a thing. We'll look at something slightly different. And if you are a C programmer, no C, love C, no MIPS, want to learn MIPS, MIPS is real easy. There's only 24 different instructions in Symphony of the Night. You can learn it pretty quickly. Get some flashcards. That's all I got for you. Adios.